Hello everyone. Today I'm going to explain about chapter 1, logic, laws of logic. In this chapter, we're going to learn about few operators and few examples for those operators. Okay. This is me, Gita, and these are my teammates. This is Diana, this is Ifa Hidayah. Okay. What we are going to learn today, in this chapter, we have to remember few logical operations. The first one, I'm going to teach this part first. And this one, my friend will explain with few examples. For this first part, negation, conjunction and disjunction. What is negation? Negation is not. So whatever we have on this side, example, when I have anything that is this in this side true, it's going to be opposite of this true, which is false. And then anything that is false over here is going to be true. So anything that is true, it becomes false. Anything that is false is going to become true. That is a negation, not. Okay. So what about conjunction? The conjunction has a very strict formula, which is it should be true and true. Then only can get true. If one of them is false, it's going to be false. If one of them or both of them false, they're still going to get false. We won't have true. So both of them, true and true only, will able to get true. Other than that, false and true or true and false going to get false, like this. And same for false and false is going to be false for the conjunction. For disjunction, or we have the simplified word, which is or. Either it's flexible, which is if one of them is true also, we still can able to get true. Example, this example here, true or true, it's going to be true. False or false is going to be false. Both of them false, obviously become false again. And then if one of them is true or false, going to be true. Same for that, false or true becomes true, not false. Okay. We're going to look on few examples of questions. Okay, in the first example, we have to create a truth table to be able to get an answer. Okay, in this truth table, for this table, we have to create a table in order to start working on our answer. Okay, first we have to start with P and then a Q. This one applies for every other question. So we start as a base, which is P, Q. For P, the formula is true, true, false, false. And for the Q, the formula is true, false, true, false. This is the actual formula. Okay, we have few steps to do this. Okay, first we have to do the smaller one, and smaller one. Then we have to apply this whole thing at the end. Okay, first we have to do this part 1. And then we will do part 2. Lastly, we will do all this together. That's number 3. So for part 1, we'll do not. Remember, this one is a not. So not P. What does not P mean? Whatever in this P group, if it's all true, it's going to be opposite of the true. Whatever is false is going to be opposite of the false. So here, if this is true, this is going to be false. So false, and these two become true. So it's opposite of P. Same goes for not. We're going to do the second part, not Q. So it's going to be the opposite of the Q. So here, true, we have to apply false. So if false, true becomes false, and then false becomes true. So this is the answer. The last one, we're going to put all this together in one place. P, not P. Remember this sign as and. If one of them also becomes false, it's going to be false. In our group, we cannot have any false. So P, not P, and not Q. So when if we read together with the symbols name, it will be easier for us. Okay, not P and not Q. So if false, false becomes false. If false, true still becomes false. And then for true, false becomes true, will get true. So our final answer is false, 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 true. Question number 2 is when to do the bracket one. Okay, first of all, before we start to do the bracket or non-bracket one, we have to create our truth table. This is a simple truth table, which must start with P, Q. P, Q. Remember, for P is true, true, false, false. For the Q is true, false, true, false. No changes in this. Okay. When we have this type of question, we wanted to finish the one in the bracket. And for that, I want to start with the not first because that is the easiest one. Okay, we can start from P, but we already have P, so we don't want to do the P. So we're going to do the not Q. For the not Q, whatever is in the Q is going to be the opposite of this Q because it's not Q. So if this Q is true, it's going to be false. False becomes true. True becomes false. And then false becomes true. So it's that. I'm going to complete the whole bracket thing because we already have P, we already have not. Now we have to finish the end. So P and not Q. this one. So P, and then we have to look at the not Q. P is true, Q is not, the not Q is false. So true, false become false. True, true become both must be true. Okay, so it becomes true. False, false become false. False, true become false. Okay. Lastly, we're going to wrap up together with this whole sequence. So that is our whole sequence, which is not P and not Q. Okay. If false becomes true, true becomes false, 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 this two become true, true. So it's going, we have to only look at this one, okay, this one, and then change it to a not, which is opposite of this part. Okay? For this question, same thing, which is we have to create a truth table. How to start? We're going to start with this one because this is the easiest one stating out. We can start from here also, not a problem. But we're going to start from this one, which is not Q. Okay, anything from here becomes opposite. So false, true, false, true. And then we have this one. I'm going to do this part. For this part is P or, okay, this one. Okay, if P or Q, any of them still have true, we still get the answer as true. If true becomes true, false, true still becomes true, false, true is true, and both of them false, so we're going to make it false. Okay, now we already done with this, and we already done with this. Now we have to join all of them with the end here. So we're going to put back the question, whole thing here, so you can easily know which one is which one. So we're going to wrap up the whole thing as part 3. We have to look at this one, this sign. This is a and, okay? So both of them must be true to get the answer as true. So false, true is not going to be true, it's false. And true, true, now we can get it true. False, true becomes false, cannot have false, if not, obviously become false. And last one is true, false is going to be false. So I hope you all understand about these 3 simple questions that we did. And my friends will explain other types of questions together with the examples and then those operators.
Next, we are going to talk about compound proposition. What is compound proposition? Compound proposition is one or more proposition can be combined to form a single compound proposition. So for example, we have M. Farah is a smart girl, and Farah is a pretty girl. For the compound M and N, Farah is a smart and pretty girl. Let's try do a question. We have open bracket P or Q on close bracket, and not open bracket P and Q close bracket. So we have to do P and Q first. For P, true, true, false, false. Q, true, false, true, false. For P or Q, if one true, it's a true. Right?
Right.
Okay. So true, 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 false, true, false, true, true, false, false, false. For P and Q, if we have two true, it means it's a true. Okay. Or true for P and Q, true, 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 false, false, because it only have one true. False, true, false, 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 false. For not P and Q, it's opposite, the opposite of P and Q. Right here we have true, so it's a false, false, true, false, true, false, true. So for the last one, P or Q, true. For not P and Q, false. Here we have N. For N, if there's true, it means it's true. So here we have true, and here we have true and false, it means it's false. Next, we have true and true, it means here is true, true. And here it's true, false, true, false. So that's it for compound proposition. Okay, next, we are going to talk about tautologies and contradictions. What is tautology? Tautology is a statement form which is true for all values of statement variables. Or contradiction is a statement form which is false for all values of statement variables. So let's say we have true, false for the statement, true, false, true, false, true, false, true, false. That we call contingency. So next, we are going to do a question about tautologies and contradiction. So here we have open bracket P and Q close bracket and not P or Q close bracket. So we have to do table first for P and Q. P true, true, false, false. For Q true, false, true, false. And for P and Q, like I said just now, for n, if there's true, true, it means it's true. And here, true, true, true. True, false, false. False, true, false. False, false, false. Okay. For P or Q, if there is one true, it means it's true. So for true, for this, true, true, true. True, false, true. False, true, true. False, false, false. For not P or Q, it's the opposite for P or P or Q. Here we have true. No. We have true. It means here is false. True, false. True, false. False. For the last one, N, P and Q, true. Not P or Q, false. For N, two true. It means it's true. True, false, false. False, false, false. False, false, false. False, true, false. So this table is a contradiction because the statement is false.
Okay, for the last subtopic, we will learn about law of logic. Okay, first of all, we have identity law. Identity law is what? It will P and T is mean true will equal to P. And if P or F false will equal to P. It doesn't matter if it's true and it's true, whatever, will equal to P. And domination law, we will get the answer equal to T and false, F. It will be like this. P or T equal to T. P and F equals to F. It was just the opposite of the identity law. And then the idempotent law, we have P or P it will equal to P, and P and P it will equal to P also. Then the double negation law, we have not in the bracket, not P will be equal to P. And then the commutative law, we have P or Q, it will equal to Q or P. We will just what do you call it? We will just switch place. Because first they have P or Q, then equal to Q or P. Then if it's this one, wait a minute. If it's this one, is P and Q, it will be Q and P. It just switch place. And then the associative laws, we have in the bracket P or Q, and then or R. And then it will be equal to P or in the bracket Q or R, close bracket. It will be the same as the below one. It will be like this. In the bracket P and Q and R equal to P and in the bracket Q and R, close bracket. It will be the associative laws. If it's a distributive law, yeah, it's a little bit complicated, but you have to remember the what do you call it, the formula. I hope you can remember it. So it's P or in the bracket Q and R. So it will be equals to in the bracket P or Q, close bracket. We will have N and open bracket P or R, close bracket. And then the below one is P and in the bracket Q or R, close bracket. It will give you the it will equal to in the bracket P and Q, close bracket. It will go or and then open bracket P and R, close bracket. We just have to what do you call it, switch the place. Like if it's P here, if it's P here, just put it P over here, and then take also this N and Q over here. Just take it, and then you close the bracket. You put an what do you call it, or, because it's the opposite of the N here, so you have to put or. Then in the bracket P, because we have P in the what do you call it, in first place we have P, so we have used the P back. Then use N and R. Well, just like that, simple as that. Simple as that, you just have to remember. Okay, for the De Morgan's law, it's a not in the bracket P and Q, close bracket, equals to not P or not Q. Just open the bracket, you just have to put not in each capital. It's the same as this one. It's the same also, not P and not in the bracket P or Q, close bracket, equals to not P or and not Q. It was just like that. Then the absorption laws. Okay, absorption laws, quite simple for me lah. It's P or in the bracket P and Q, close bracket, it will get P. If it's the opposite one, like P and open bracket P or Q, close bracket, it will also get P. It doesn't matter. And then negation law. Negation law, you simply get the true or false answer. Then you see this here and this here. It says P or not P equals to P. P it means true. And if it's P and not P, it will mean it will give you equal to F. It means false. To me, it's simple because it already give you the answer is true or false. Okay, as you can see here, we have one question. It's a simple one, so bear with me. Okay, so you can see here in this bracket, we have P and Q. In the outer of the bracket, we have OR. And we have one more bracket, we have P and not Q. Okay, and then as you can see over here, you must look which one you want to use. Okay, if you ask me, of course, I know the question already.
You know the answer.
Yeah, so I will use the distributive law. Why? Because as you can see over here, this one, wait, let me put it. So you can see here, it's just the same thing. It's just that this R you just have to change with the not Q. Okay, for you to understand the why I use the distributive law. So we can get a smaller, we get the smaller one. Okay, so it will be like this one. Wait a minute, let me write it. P and in the bracket Q or not Q. Close bracket. After you write this, you have to write what kind of law you use. So if you want an extra mark, if you don't want it, so don't write it. So this distributive law. All right. So what come after this one? So let's see here. We have to settle in the bracket first, okay? We have to settle this one in the bracket first. Okay. If you can see here, let me show you a little bit. So which one would you choose?
Negation law.
All right, good. We're going to use the negation law. Because if you use the negation law, you see here, this is Q or not Q. Okay. If you use that, you can just simply get this one. Wait, let me see. This one. Okay. Just change the P with Q. It'll be the same. So it's going to be like this. Wait, let me show you. It's going to be P and T. Why T? Because I already told you. Because I already told you this. You're gonna get an equal with P. So it's good. Don't forget to put what kind of law you use. Negation law. Right. Good. Also, the last one. Which one would you choose?
Identity law.
Okay. Good one. So you can see here P and T. So if it's at the upper one, you can choose this one. So what's the answer will be? P. Right. So the answer will be only P, right? Don't forget to put identity law. Right. This is the answer. Okay. So for the conclusion, for the topic of 1.1, propositional logic, we just learn about a proposition is a statement that is either true or false. Okay. For the 1.2, logical operators is a kind of ifs. Following logical operators is number one is negation. Negation is a not. Not is the symbol is like this. And then for number two is conjunction. It's an and. And is the symbol is like that. And number three is disjunction. Disjunction, the symbol will be like this. It means or. And then the exclusive or is number four. The symbol is like that. Okay. And then for the implication, number five, if we call it if then. If then the symbol will be like this. It's like an arrow, but you have to go on the right side. Yes. And then for the last one is biconditional. Okay. And then biconditional is if and only if. If and only if, you have to go both ways, left and right. Okay. For 1.3, compound proposition. Compound proposition, if you remember my friend over here talk about, is about a girl named, wait, let me show you this one. Okay. We have M, Farah is a smart girl, and Farah is a pretty girl, and it will be compound as in M and N. What we're gonna say about it? We're gonna say as such as Farah is a smart and a pretty girl. Okay, for 1.4, tautologies and contradictions. Tautologies is for statement which is true, and contradiction is the false one. Okay, if it's other than tautology and contradiction, the proposition will be called contingency. Like that. Okay, for the last one is my topic. And of course, you have to remember about the law of logic. If you want to do more, if you want to know more, you have to do more exercise. If you not do more exercise, then you have a hard time to remember this one.
Yes.
So do more exercise and good luck.
That's all for me. Thank you.
Thank you. Bye-bye.